Hi everyone, my name is Jacob Kashiwagi. I am a senior researcher at the Performance-Based Studies Research Group, presenting the paper, The Application of the Best Value Approach in Janitorial Services. This research was originally initiated by a city that was looking for a procurement and project delivery model that could help them be able to outsource services that they didn't have a lot of experience in, that they were performing in-house previously. They were also dealing with limited budget and very high stakeholder expectations. So they were looking for a more efficient process that could get better services for a lower cost. They heard about the Performance-Based Studies Research Group and about the best value approach, the project delivery model that we have been testing out throughout the world, especially through CIB W117, which goal is to use the best value approach and to see the value and the efficiency it can add to a service or project all over the world. And so you can see the performance that we've done and the different organizations that we've partnered with to do this. But what the city really bought into was the idea between a client-centric approach versus a vendor-centric. The city traditionally was doing a client-centric approach. This client-centric approach requires the client to be responsible for all the major areas of a project. So the client's the one making the decisions. The client is the one that needs to have the information expertise to make the requirements for a service. As well as a service moves on, the client is the one that will be responsible for the project management and risk management of the project. A vendor-centric approach is very simple. It's when the client recognizes they might not have the expertise, and thus they require the vendors to be responsible for all the major areas of a project. Thus, the vendors are making the decisions. The vendors are differentiating themselves, so the client doesn't have to worry about it and doesn't have to have that expertise. And so they wanted to try a test project. How the best value approach does this is basically it simplifies the project delivery model. So when they're making the RFP or they're trying to get vendors to bid for these services, they don't need to know anything. They just put down what currently they're doing or what they think they need, and they tell the vendors, it's your responsibility to actually determine how we're going to do this and what the requirements should be. Now, in order to select these vendors, they simply tell the vendors, we want to know in simple performance metrics what makes you different than other vendors. And you can see the criteria. They ask them to turn this in multiple ways, in their expertise, in their ability to minimize risk, and in the value added things that they can give to that project or service, plus to turn in their cost. And so once they turn all these things in, it becomes very apparent which vendor is the best for the service, and they let that vendor come into the clarification to actually lay out the entire plan for a service, what's going to be expected, how they're going to measure the performance of the service, and what should be done throughout the entire service. And so the City of Longmont wanted to do this. The contract they're going to do it on is their janitorial services for their 19 facilities. And so you can see the requirements that they put down. This is not really the requirements, this is what they currently were doing. This was very easy to do for them, so this RFP was done very quickly. And these are the criteria again. You can see the major weighting was on their ability to perform or their expertise, as well as on the interview, making sure the person who's managing the project understands what they're doing and can explain it very simply. And so here is the evaluation matrix, and you can see all the criteria were evaluated on a scale of 1 to 10, 10 being the highest, 1 being the lowest. The evaluation was very easy because if they turned in a document and it had performance metrics and was understandable, it received a 10. If they couldn't understand it, they didn't know what was going on, it was a 5. And if it was very low performing and they didn't think they could do the work, it was a 1. When you look at this, it became very clear there's only 2 vendors that have the performance capability to deliver this service. And when they looked at it, their performance numbers were very similar and the ratings were very similar. So they went to the cost and they found out that one vendor was half the cost. In fact, the highest evaluated vendor was half the cost of the other vendor, who was actually the incumbent. And so there was no choice for them. They went with the highest ranked vendor and they brought them in. As they brought them in, they looked at their level of expertise. They looked at what they put down, which was they had done similar cities. They had expertise in hiring and training staff, as well as ensuring that any issues was dealt with to high quality and to the customer satisfaction. With the risks, they identified all the risks the city was worried about, which was we're going through the pandemic at that time, so they worried about their supply shortages, the different type of disinfecting services they had, as well as their turnover rate, making sure they had enough employees. They also required this vendor to turn in their documentation on anything they said. So here's the documentation on the 3 other cities and their comparison to the city that was buying their services. And then, of course, they require them to prove their low turnover rate, as well as being able to respond to issues in 24 hours and 100% satisfaction of the clients. They were able to explain what their numbers were, as well as turn in the forms and the documentation for it. Then they came into the clarification, and in the clarification, this is where they require the vendor to lay everything out. And you can see the vendor identified, look, these are all the things that we're going to do. This is how we're going to measure it. This is the frequency we're going to measure it. And they even put the requirement for that area on what was acceptable, what would be considered high performing or not passing. So you can kind of see that on the screen. They went through explaining in terms of their documentation of it. This is how we're going to document it. This is how we're going to show customer satisfaction, even down to the level of each building and how they would document every complaint. So you can see the results. In comparison with the process the city was doing before, you can see the best value vendor-centric approach had much higher ratings and provided much greater value and satisfaction. And you can see the efficiency of it in terms of how many pages the RFP scope of work had to be, as well as how much effort the client had to put in to finding this vendor and the time it took to procure them. And you can see not only did they get a high-performing vendor, but they also were able to reduce their costs almost by half with this vendor's proposal. And everybody was very satisfied. Now, unfortunately, because it was a COVID pandemic, they weren't able to go through with this contract. The higher-ups of the city, right when they were about to sign, said they no longer needed the janitorial services like they expected. And so this did not go through, and we can't give you an update on the performance of how they did. But it shows just by the clarification and the layout of their plan, just how effective a vendor-centric approach can be. I'll be available for any questions. Thank you so much. You have a great day.
Thank you, Jacob. Is there any question on the floor? Probably for the audience, you may chip in later. So let me ask Jacob one question first. Jacob?
Yes, Dr. Chia.
Yeah, Jacob. Yeah. Just now I noticed that in your slide, there's one slide you're showing the selection metrics, which beside the race value added and another item I can't recall clearly, but it do include another criteria that is on the interview, 35%. My question is, what are the details of the interview? What you try to find out from the interview, and it costs the weightage of 35%.
Yes, so during the interview in this type of approach, we are not trying to find any technical details of the service that will be provided, but we're actually trying to figure out if the person who's going to manage the project has a vision and understanding of exactly what it will take to get the project completed or the service delivered, as well as do they understand what the end result will be in metrics. And so every question that is asked, we are looking for a response that has a performance metric to it and that shows that this person understands exactly what needs to be done and can explain it in a very simplistic manner that the client can understand.
I got it, Jagat. So it means you try to understand the person who undertake the job. They are really understand the concept of the best value.
Yes.
Okay. Thank you, Jagat. Is there any question from the floor? We still have 2 minutes. If no question, Jagat, do you have anything extra you want to say?
No, just thank you everyone for listening, and yes, thank you for your time.
Okay, thank you very much, Jagat. So the next presenter is Ruiz. Am I right? Let me check. Yeah, there's Ruiz Renato. The paper entitled Being Applied to Budgeting and Quantification for Design Building Companies in Brazil. Ruiz, are you ready?
Yes, good afternoon.
Yeah, good afternoon. You may introduce yourself, and the floor is yours. You proceed with your presentations.
Okay, I will share my presentation. Wait a moment, please. Are you seeing the slides? Are you seeing?
Yeah, looks good.
Are the slides running?
Yeah, if you just want to put it into full screen mode, the presentation mode.
Okay, are the slides running?
At the moment, it's just up on one slide.
Okay. My name is Luis Cardoso. I'm professor in Department of Civil Construction Engineering, Polytechnic School, University of São Paulo, Brazil. My paper is Being Applied to Budgeting and Quantification for Design Building Companies in Brazil. The content of this presentation is context and purpose, budget in quantification, definitions and requirements, limitations being for quantification and proposal for overcoming, case study, results, conclusions, and recommendations. Context. Increasing use in BIM on DBCs in Brazil is a trend. Among the advantages, pointed with emphasis, automation for quantification for budget, based on BIM apps usually used for project. However, those applications, Revit, ArchiCAD, provides a relatively small part of information needed for elaborating the budget. The third is also pointed as an advantage of use BIM, the automatizing not only the quantification, but also the budget itself using other applications that involves high complexity. Usual process of a budget is already entirely automated for quantification using applications and ERP systems. Only the stage of quantification survey continues to be basically manual, cases, lot of work, time, and greater possibility of mistakes. The literature review point gap in this approach, considering the DBC context in Brazil. Objectives. The objective of this paper is demonstrate conceptually and quantitatively the limitations of the usual BIM project models to obtain the necessary information for quantification and budget. Present and alternative to overcome these limitations with parameterization and small increase of modeling. Assess the potential gain to be obtained from increasing the automation of quantification. For this, a case study was conducted. Budget requirements. Project with defining all the services with their respective geometries and technical specification must be complete. All costs, direct and indirect. Tractability. Results coherent with market reality. Proper precision. Qualified professional with legally defined responsibility. Quantification requirements. Possibility of tractability and conference. Easiness of alteration. Clear and explicit rules of checking with adherence to measurement criteria. Maximal automation possible. Limitations being for quantification and proposal for overcoming. Models for project BIM, basic project made inherit, load 300, architecture and structure, AE design. A. Information not associated with the model, basically indirect costs. Proposal, estimated and quantified according to the usual manual methods. B. Elements not modeled for not being part of the scope of the AE design. For example, earthworks, foundation, and retaining walls facilities. Proposal. For some meetings, usual manual methods. For others, parameterization in the structure elements. C. Elements that are part of the scope of the AE design, but that are not modeled. For example, steel for structure, formwork and structure shoring, wall coverings. Proposal, steel, formwork, and structure shoring, parameterization in the structure elements. Coatings, modeling, and parameterization. That's only item for which modeling is proposed. D, not considering measuring criteria. For example, labor in walls and wall covering. Proposal, parameterization. Case study. Medium standard residential building in the development located in the city of São Paulo. 29 floors. Total area, 16,000 square meters. Schedule, 24 months. Budget, 367 services. Quantification, 67 spreadsheets. Hypothesis, AE design, model in Revit, load 300, with parameterization according proposals. Identify and quantify which services items in the budget could have their quantities automatically obtained. Results. The total items could be automatically obtained from the model. 190, 32% of the total items. 36% of the total costs, all direct costs. With the proposals, total items quantified automatically, 210. 57% of total items, 67% of total costs. Total items, 76%, total costs, 83%. Conclusions and recommendations. The automation gain is quite significant with reduced additional modeling work and parameterization. For the conditions of the case study, the increase was from about a third to near 60% of total widths and near 70% of total costs. Recommended that further studies be carried out with a view to applying and evaluating this guideline for models. It's also recommended to evaluate the limitations for present and supporting information for use in the budget, which was not done in this work. Reference. Thank you.
Thank you, Luis. Is there any question from the floor? Okay, Luis, just to check with you, for your quantifications or your BIM model, what software you are using?
For quantification, I use the information by Revit.
Revit.
Revit, yes.
Okay. So you are using the quantity tick off, QTF, or QTO, quantity tick off, or just Revit itself?
I use only Revit,
Okay,
not the other application.
I see.
The information by Revit only one, not the other application.
Okay, only using Revit. All right.
Yes.
So, any more questions on the floor? If no questions, we will proceed with the third paper, authored by Mustafa, Profit Factors in Real Estate Projects, a comparisons of academic study and expert opinions. Danny, are you ready with the recorded video? Hi, Mustafa.
Hello everyone, good afternoon. Yeah, I am ready.
Yeah. Okay, you may proceed. Sorry, I can't hear anything.
Yeah, I think there's an audio problem. I can't hear my presentation.
Oh,
Hello everyone. Today I'm going to present you my study.
Okay.
Paper which is a part of my dissertation is about profit factors in real estate projects, a comparison of academic studies and expert opinions. My name is Mustafa Barış Fazilet and I'm a PhD student, and my advisor is Associate Professor Dr. Deniz Artan, both of us from Department of Civil Engineering in Istanbul Technical University in Turkey. My presentation is divided into 5 parts, and it's beginning with introduction and then going on step by step with literature review, research methodology, findings and discussion, and finally conclusion. Let's start with a very simple question: why we make a project? Generally, there are 3 different goals to make a project. To solve a problem, projects may be carried out by governments to solve a problem and to meet the public needs. And the main aim of the public projects is to serve citizens, not profit making. Gaining prestige may be another reason for doing projects, and earning money. Primary concern of private enterprises is to maximize profit under certain constraints. And the subject of today and this study is to determine what affects the profitability, which is the main goal of the private enterprises. Primary goal of private real estate investment project is to make profit. But today, especially in Turkey, when we look at the projects of many companies are examined, it's evident that there are significant differences between forecasts and realizations in profit. So it's critical to be aware of the factors that affect profitability to prevent discrepancy. And this study focuses on medium and large scale mixed use real estate investment projects. Real estate investment project development is a complicated process, and understanding the stage is fundamental for being successful in this business. In this process, the parties involved in the project have an impact on the project profitability. Also, profitability factors should be examined in two groups, namely cost and revenue. Briefly, project profitability is the difference between the revenues and costs resulting from the decisions and practices carried out by project stakeholders at each stage of the investment cycle. Because of time limitation, I am skipping details of cycle, but understanding is very critical to being successful in profitability. As I mentioned before, there are mainly two components of profitability, namely cost and revenue. The factors should also be examined in two groups during the literature research phase. As mentioned in a previous review paper by me and my advisor, there are many factors related to cost and revenue in the literature. In the first step, 191 factors were identified and categorized by an in-depth review of literature. 82 of them were cost-related factors. Also, 109 of them were revenue-related factors. And when we look at the cost-based literature review, cost-related factors were categorized into 9 groups. And it's seen that 6 of 82 factors are frequently analyzed in the literature. And in order to use time efficiently, I'm skipping the detail of literature review. But if you want to see the details, please check the previous review paper. And when we look at the revenue-based literature review, which is another variable of profitability, revenue-related factors were categorized into 8 groups, and also 5 of them are very common in the literature. This study identifies and analyzes the determinants of profit in 3 steps: literature review, frequency analysis and normative refinement technique, and face-to-face interviews. And the first step of this research, as shown in figure, was previously published as a literature review paper, as I mentioned before. And revenue and cost-related 191 factors affecting profitability were presented in that study. And in the second step, 191 factors were transformed into 66 factors based on the frequency analysis and normative refinement technique. And in the last step, face-to-face interviews were conducted with 15 senior managers working in the Turkish real estate sector and Turkish real estate and construction sector. Interviews with experts, which took approximately 2 to 3 hours, consist of 2 parts. In the first section, experts were asked about the factors that affect the profitability in a semi-structured interview format. In the second section, the opinions of experts were asked in order to validate the 66 factors identified from the literature in a simple ticket format. In the first part of face-to-face interviews, 15 experts gave 577 answers in total and tried to explain the factors that affect profitability. In the second part, experts validated 66 factors obtained from the literature. After the interviews, 577 answers organized and compared and converted into 96 factors by normative refinement technique. And as a result, 2 sets of factors were established. 66 profit factors obtained from the literature review and 96 profit factors obtained from the face-to-face interviews. And then 2 sets of factors were compared in order to understand the similarities and differences in the factors acquired from the academia and industry. When we look at the two sets of factors, the field research revealed that some factors were mentioned by the participants but were not included in the literature, and some factors were included in the literature but not stated by the participants. As an example, these 9 factors that focused by experts but not mentioned or mentioned very infrequently in academic studies. On the other hand, these 9 factors focused from the academic studies but not mentioned very infrequently by experts. Also, when we examine the 96 factors from obtained from the face-to-face interviews, these 6 factors are the most frequently stated factors by participants, experts. Let me clarify and summarize to better understanding, because here's the final point. We have 2 sets of factors. First group is based on literature and also validated by experts, and second group is obtained from the face-to-face interviews. And when we examined these 2 groups, it was seen that some factors had very broad meaning, and some factors had very specific meanings. And some broader factors were determined to cover other more specific factors. By the way, I'm checking my timing. Therefore, all these factors were taken into account by normative refinement technique, and 78 factors were decided as a final factor list. You can find the detail of final factor list in table 3 in the paper. As I mentioned in the introduction section, this study is a part of my dissertation. Following step of this research is factor analysis to get factor groups by using the final profit factor list obtained in this paper. And 2 contributions are expected from this study. It helps professionals to understand which factors they needed to focus on, and it provides an extensive list of profit factors for future research. This is the end of the presentation, and if you have any questions, you have contact with me directly via my email address, and thank you for your listening and attention.
Thank you again.
Thank you, Mustafa.
Thank you.
Is there any question on the floor? Mustafa?
Yes.
Probably, can you just highlight to us, you have concluded that there is a 78 profit factors. So based on the 78 profit factor, can you highlight what are the most significant? Probably 1, 2.
Yeah. Actually, this is the next part of this research, because as I mentioned, this is a part of my dissertation, and the following step there is gonna be factor analysis, and there is gonna be ranking RII study. But if I highlight some of them from the literature based and face-to-face interviews, there are very significant factors from 78 factors. For example, records and experience of past projects is very important factor, and market research, determination of target population and project segmentation is very important factor for profitability of real estate projects. And let me say a third and last one. For example, I'm checking the factors. Financial risk, for example, inflation and exchange rate risks are the another very important factor for the especially in Turkey, for profitability of real estate investment projects. This is the three of them, I can say. But as I said before, following step of this research is factor analysis, and at the end of this analysis and this study, RII ranking of these factors are conducted.
Okay. So I summarize up. You have like past project, marketing, financial, inflation. Those are the significant factor at this point of time. What you found out.
Yeah,
Thank you
based
very
on
much.
the literature and based on the face-to-face interviews with experts.
Okay. Thank you, Mustafa. Thank you for your paper.
Thank you. Thank you. Have a good day.
Okay. So we have a last but not the least paper entitled A Data-Driven Approach for Monitoring Performance of Equipment in Construction Earthwork Using IoT and Cloud Computing. The author is Elham Mohammadi. Elham, are you ready?
Yes, hello everyone. Yes, I am ready.
Yeah, okay. This is a recorded video, right? Danny, you can start to present.
Hello everyone, and welcome to this presentation. I am Elham Mohammadi, and I'm going to present our paper on a data-driven approach for monitoring performance of equipment in construction earthwork using IoT and cloud computing. The co-authors of this paper are Dr. Cairo Gage and Professor Mohammed Qasim. In this presentation, I will give you introduction to the research project, and then I will talk about the problem statements and our research aims. And then I will explain our research methodology and the pilot study and the results. And finally, I will conclude my presentation with a summary of our research implications. In construction projects, particularly in equipment-intensive projects, the project performance really depends on the productivity of the utilized equipment. The low equipment productivity can lead to low production rates, and therefore monitoring productivity and performance of equipment is a key task to identify deficiencies and their root causes. The problem is that the traditional construction operation monitoring is based on manual data collection, involving direct observation of activities, using sampling, interviews, or surveys. And it's really challenging because of the complex nature of the site activities and the wide range of equipment operating at the same time. This makes the method time-consuming and at the same time error-prone. In recent years, alternative technology-enabled solutions have become increasingly popular for capturing data at construction sites. However, not enough attention has been given to developing a robust performance monitoring system to provide data-informed insights in real time or near real time. So in order to have a system like that, it's necessary to streamline data capturing, data processing, and analysis along with the real-time data visualization. And to accomplish these tasks, infrastructure must have high capacity for storing huge amounts of data, as well as power to handle the computational load of data analytics and corresponding AI models. Therefore, the purpose of this paper is to develop a cloud-based framework for streamlining the data capturing, data processing, and data visualization for equipment performance monitoring in construction earthwork projects. For this study, we utilize Google Cloud Platform or GCP as a cloud system. And basically, we integrate all the required tasks using this cloud provider. Generally, a cloud system like GCP is a network-based model to enable easy and on-demand access to scalable and affordable computing resources such as networks, servers, storage, and so many other services with minimal management effort and interaction from the service provider. And these services can be accessed on a pay-as-you-go basis. For the framework, first we have data acquisition step. Different sensors data such as equipment speed, longitude, latitude, altitude, accelerometer, and gyroscope data were uploaded to the Google Cloud storage in a CSV format. These data were captured using smartphone applications, and the smartphones were mounted in the cabin of the equipment working on construction sites. The second step of the framework is data processing and analysis. For this part, we have a Python script to process the sensor data. The Python code defined and executed within a Google Cloud function. Google Cloud Functions are a serverless computing approach that allows the code to be deployed and run on demand, while the cloud infrastructure takes care of the server management and scaling. We also use Google Cloud Scheduler to basically trigger this cloud function. And Google Cloud Scheduler automates any job across different Google services, again in a serverless manner. The Python code developed in the cloud function first checks if there are any new files have been received since the last check. And if the resource is an excavator, the corresponding accelerometer and gyroscope data will be used as inputs for a deep learning model that we trained using Google Colab for activity recognition of excavators. And Google Colab is a free web-based Google Cloud computing platform. And we also use Google AI platform that we host our train model in Google Colab. We have a separate published study that explains the detail of our deep learning solutions. But generally, the deep learning model discovers if the excavator was active or inactive and updates the status of the resource. For the trucks, the truck status is based on the location, which is recognized by longitude and latitude and the predefined areas of loading and dumping. And all these process data were saved in Google BigQuery in near real time. BigQuery is a powerful Google Cloud data warehouse designed to quickly and efficiently ingest, store, and analyze the data. And finally, for the visualization part, for the visualization step, we use Google Data Studio. Google Data Studio is a free dashboarding software that connects to various data sources like BigQuery to extract the data and from data warehouse and visualize the data. We tested our proposed framework in 3 pilot studies to evaluate the functionality and capability of the framework. The first pilot study was conducted in a demolition project with a hydraulic excavator, and the goal was to find the utilization ratio of the excavator, as shown in the visualization dashboard in the top left pie chart in this figure. The second pilot study was conducted using a vehicle simulating a round trip, including loading, hauling, dumping, and returning tasks of the rock. The smartphone was mounted in the vehicle dashboard, and the vehicle completed the round trip within a predefined zone. Based on the predefined loading and tipping zones, the vehicle's time spent in this area are calculated using an algorithm for automatically recognizing each task on the round trip. The time for traveling from the loading zone to the tipping zone was considered hauling, and from the tipping zone to the loading zone was considered returning. And each task's actual duration was recorded to evaluate the accuracy of the algorithm. As shown in the dashboard, the top right pie chart shows the percentage of each task recognized by the algorithm in a round trip, and the value for each state is very close to the actual percentage with a maximum absolute error of 4.3. And finally, the third pilot study, we have several trucks working on an earth moving project. The distance over time graph presented at the bottom left of the dashboard in this figure shows the distance moved by the truck over time. From this graph, it can be concluded that if there is any bottleneck or little movement by the truck comparing with the threshold defined by experts, it could be an indicator of the bottleneck or delay in the truck operation. As you see the sample of this in the second figure. And finally, the theoretical implication of this work is in both the holistic and the automated nature of the proposed framework compared to most of the framework and approaches that we identified in the literature review of this study. And the key practical implication of this study is introducing and demonstrating of an efficient infrastructure which enables project manager to focus on the analytic component of the project performance instead of hardware and IT infrastructure of the digitalized system. And we believe that the result of this study can contribute to the improvement of productivity of airport projects and construction projects generally. Thank you very much for your attention. If you have any question, feel free to ask here or contact our corresponding author, Professor Mohammad Kazem.
Thank you, Alpan. That's a very interesting paper. Any question from the floor? We still have a couple of minutes here. Elhan, may I ask for your study, the program or the algorithm, is it written by you or you are using some other available program for your study?
Yes, because my background is computer science, yes, I've done the script and the algorithm by myself. So yeah, and we utilize the Google Cloud services to just manage our codes and scripts in a cloud-based solution.
I see. So you have written your own coding, your own script. Yeah. Okay.
Yeah, we have separate part. We have the machine learning parts that was in studies that we integrate in this study, and also the part, the script that we automate the different discoveries for different aspects of the trucks and things like that. And obviously automating the server parts, that how we can in a script we can connect different services from Google Cloud services to be able to integrate them, and they can talk to each other and things like that. Basically, kind of managing the service of the cloud services.
I see. So for the script writing, have you complete or how many percent you have completed until now?
Sorry, one more time, can you repeat your question?
I mean, for script writing, have you completed your script writing or you still in progress to complete all the script writing?
At the time that we had basically this research project was active, I did whatever I needed for that part of project sorry, my son is awake now, and for the part that we needed, but I'm working on different type of project at the moment that I am trying to use the same methodology in terms of the working with the cloud functions. So I probably need to extend my script in terms of talking to different Google Cloud Service solutions. But whatever we have, it was for that project, and it was enough for that step.
Okay, thank you very much, Elham. So is there any other questions on the floor? If no, then I think we can conclude these sections. Thank you very much. Thank you, Danny.
Hey, Doc.
Yeah. Okay. Hopefully to see you some of this day. Thank you.